right, so let's work on reading graphs and tables. This is a really important part of statistics as well. This chart is called a stacked bar chart. It's stacked because you can see here for week 4, we have a gray box and then we have a green box on top of that. And so that's information for 2 different stores. The gray is for store A and the green is for store B. So we have weeks on our vertical axis here, week 1, 2, 3, and 4. Along the bottom on what we call our x-axis, that's the number of new customers. And then the gray is for store A and the green is for store B. Now, normally we see bars up and down vertically, but this is a good way of demonstrating what's going on with the bar chart as well. And you'll see these a lot in the news where they have the bars going horizontally. So they said in week 1, how many new customers arrived at store A? So we're going to come over here to week 1. We know that the gray is store A. So we're just going to come right here to the gray bar. And that tells me that there are 45 new customers in week 1 for store A. All right, this graph is the same idea. It's again a stacked bar. You've got weeks on the vertical. You have number of new customers on the horizontal or the x-axis. Again, the gray is store A and the green is store B. And they want to know during which week did store A and store B receive about the same new customers? Okay, so let's look. Week 1, let's change our marker here. We've got 37 versus 40. That's pretty close. Week 2, we have 24 versus 39. That's not good. Week 3, we have 40 versus 28. Those are not about the same. And then finally, week 4, we have 15 versus 25. So I would say week 1 is when store A and store B received about the same number of new customers. So hopefully you see I'm grabbing those numbers right from the bar. The first column here are the gray bars, so the numbers inside the gray bars. The second is inside the green. All right, let's take a look here. We have a pie chart. So we have lunch is blue, breakfast is red, snacks green, and dinner yellow. Okay, and it says snacks and breakfast together make up about what % of total daily calories? So with percent, I need a piece over the total. Okay, so let's go ahead and add these up. If you add these 4 numbers up, you're going to get 2,000 total daily calories. So if we want to know the percent, we're going to put the snacks and breakfast. So breakfast is 460, snacks 180. So I'm going to go ahead and put 180 plus 460 over 2,000. Let's see what we get. All right, so if you put that in your calculator, you would get 0.32. Okay, so that's great, but that's a decimal and we want percent. So we know that to get percent, we're going to slide the decimal point to the right, and that would give us 32%. So snacks and breakfast make up 32% with this data of our daily calories. All right, let's take a look at this one. Same idea, we have a pie chart with lunch, breakfast, snacks, and dinner. What % of daily calories comes from snacks? Okay, so we're only going to grab the snacks, but we need the total again. So if you add these 4 numbers up, you're again going to get 2,000. So that's our daily calories. Snacks would be 215 calories over 2,000 calories. If you put that in your calculator, you're going to get, well, you get 0.1075. I messed up right here, sorry. And that's a decimal, so we want percent. So we would have 10.75%. Now again, notice with my stat lab, they put the percent outside the box, so you really just have to put the 10.75 inside the box. All right, we have another stacked bar. This time, across the bottom on the x-axis is the number of medals. This is a 5th grade Olympics. That's what the title up here says. We have the green is Mr. K's class, the gray is Miss T's class, the blue is Mrs. P's class. Okay, along the vertical axis here is the type of medal. So we get gold medals, silver medals, bronze medals, platinum medals, and then the data is inside of these stacked bars. So the number of students who earned a platinum medal overall is, so platinum is up here. We want to add Mr. K's class plus Miss T's class plus Mrs. P's class. So we have 10 from Mr. K's class. We have 1 from Miss T's class. And we have 2 from Mrs. P's class. So that gives us 13 students overall, lucky 13. So 13 students earned a platinum medal. Okay, this is called a pictograph. We're looking at the annual fruit production in top producing regions. So it tells me that 1 apple is 10 million bushels. It has that over here. So if they cut the apple in half, of course, that would be half that. That would be 5 million bushels. And you've got different regions here. You have the southern region, mountain region, central, lake, coastal, and northern. So they want to know, looking at this chart, which region produces about 30 million bushels of fruit. So if 1 apple is 10 million bushels of fruit, we would need 3 apples, right, to be 30. So that looks like it's the lake region here. Lake region has 3 apples. Coastal has 2 below it, and above the central has, what, 4.5 apples. So 45 million bushels. So we're going to go with lake. Just a different way of showing data. All right. We want to make a vertical bar graph. So it's not going to be stacked and it's not going to be horizontal like those other ones we looked at, because we only have 2 rows of data. We have the year here, 1970, 1980, 1990, and 2001. Not quite sure why they didn't just use 2000. This is what we're going to put along the bottom. So this is going to be what we call our x-axis is going to be the year. And then the sales are going to be on the vertical axis, or what we call the y-axis. Okay, so we need to have years along the bottom, 1970, 1980, 1990, 2001. So A has that, right? B has that. Now C doesn't. C has it flip-flopped, so we don't want C. We don't want the years on the y-axis. Okay, now we need to look at our sales. So if you look, in 1970, we had $46 billion of sales in the restaurant, food and beverage sales. So, and then 1980, we had 120, then 236, then 396. So you can see these bars should be increasing, right? Because the sales in billions of dollars are getting bigger and bigger. So A would not work because look, those bars are going downward. That's not going to work. B is good because these bars are getting bigger as we go along. And by the time you get to 2001, you're at 396 billion, which is almost 400. Okay, so for this one, we're going to go ahead and do what we call a class frequency. So these are golf scores for an amateur golfer. All right, looks like I've got 15 scores. They are out of order. They're not in numerical order, but that's okay. So we are going to make what we call a frequency distribution table. So we're kind of going to use tick marks for this. The first interval, we want all of the scores that are between 70 and 79 inclusive. So we're including 70, we're including 79. So let's see what we have. Let me use the yellow. So we have 77 right here, so that's one tick mark. We have 73 right here, that's a second tick mark. That looks like all of the 70s. So for 70 to 79, we only have two scores that are between 70 and 79, including 70 and 79. Okay, let's try 80. Okay, so we have 84, that's one tick mark. We have 85, that's another tick mark. We have 83, that's a tick mark. 87, 87 again, and 82. Now notice when I got to 5, I crossed through. So this is called tallying. So when I every time I saw an 80, I just added another tick mark. When I get to 5, I cross through it so that I can easily count up the 5s. I could do 5, 10, 15 if I had a ton of these. So this tells me that I had 1, 2, 3, 4, 5, 6. 6 is the frequency for 80 to 89. All right, let's do 90. All right, so I have 95. I have 90. I have 95 and 92. All right, so that means I only have 4. And then finally, let's do 100 to 109. That's what I have left. So it looks like I have 3 of those. Okay, so this is called a frequency distribution table. We're going to do these in chapter 2, but we're just getting you started and looking at these tick marks. This would be 1, 2, 3 if you were doing tick marks. With this graph, we again have years across the bottom, 1982, 86, 90, 94, 98, and 2002. And we have average number of goals per game on the vertical axis here. This is the World Cup goals per game average. And so like 1982, we would come up and it looks like it would be 3.8. Over here at 1990, if we come up and look over, that would be at about 3.2 and so on. So we could read this data if they asked us for certain years what the average number of goals were. But that's not what they're asking me. They say between 1998, which is right here, and 2002, did the average number of goals per game increase or decrease? Well, they decreased because in 1998, we were up here at almost 3.7, and 2002, we're down here at 3.5. But you can also see because the line graph is headed downward, we were decreasing. If it heads upward, we would be increasing. So between 1998 and 2002, the average number of goals decreased.